The brothers Wisp. The brothers Wisp, brothers Wisp. The brothers Wisp. The brothers.
You're now listening to Greg. It's the Brothers Wisp. Let's take.
Hey everybody, it's Tommy with the Brothers Wisp. I'm here at WISPAPalooza 2025 at the Astrom booth and right today I have Brighu Ravi and we're talking about a cool radio. Introduce us please.
Thank you. Hi, Thomas. So my name is Brighu. I'm from Astrome Technologies. I'm the head of commercial business. Along with me is Venkatesha, Anantharao. He's the head of programs at Astrom as well. So we're here, and this is an exciting time for us because we're doing a lot of stuff over here. This is our flagship product. It's called Gigamesh. Interesting day for us and exciting as well because this is the launch of our third generation product. We've been around for 10 years. Astrome Technologies is a deep tech engineering company, and we've been offering technology solutions to WISPs as well as MNOs, telecom operators, so that they can overcome some of the the challenges that they face by providing connectivity to different ecosystems. So when I say ecosystems, we're talking about rural as a major ecosystem where connectivity becomes a problem. Fiber is an issue to lay it out there from an economics perspective. So that's where you have something that's wireless that comes in, kicks in. Gigamesh is an E-band solution, which operates at between 71 to 86 gigahertz, and is offering a pencil beam and big differentiator for us, or rather major USP is that this has the capability to auto align, which means that because of any weather conditions, if there's any kind of misalignment that happens due to thermal energy, or it could be wind or rain, the capability of the system backed by its software allows it to align very quickly. When I say very quickly, we're just talking about a few seconds. The installation for this is also quite fast, where most rig operators, they have to do about 15 to 20 hours in just installing their radio. We just need about 30 minutes, and then we're good. So it offers great OpEx savings, operation expenses as well as efforts for operators to set a radio up. Now, there are issues that do happen with E-bands because of the pencil beam that comes in. So I'm just going to spend a few seconds over there or minutes over there. So there's something that's called the sunflower effect, caused because of degree changes with the sun's energy. That leads to 0.5 degrees misalignment. We also have the wind sway effect when you have towers on hilly areas. There's a bit of a sway that happens. Then there's, of course, rain fade that is caused due to heavy rainfall. The alignment starts to fail. But because of a pioneering technology that we've been able to crack, the system is able to align itself automatically. You can be sitting in your premises. You don't have to be there. There's no manual effort required. The azimuth as well as the pitch can be monitored as well as operated electronically.
So is that a physical alignment change, or is that how do you do the auto alignment?
The auto alignment can be done.
I'll re-ask the question.
Yeah, perfect. I may be going in different directions there.
Yeah. I'm just gonna try and kind of follow along really quick. Do you have, there's point to one radio multi beams, yes. Okay, and we'll talk about that. Yeah. Is there a meshing portion of this? This is just like question.
Meshing.
So like
meshing is
one
not
radio
that
can be connected to two radios, and two radios can be connected.
We can
to...
do multiple point to points. Mm-hmm. So over a long range, we are able to offer connectivity. It's restricted to about 2 to 3 radios.
Okay.
So we are more multiple point to point rather than point to multi-point.
Okay.
So we can just stick to that.
Multiple point to point.
Backhaul type of things we are addressing, but it can go to TDM, whatever you said, multiple rules can be formed.
Okay.
There are the software features we need to add.
Okay. All right. So then, quick question for the alignment, that auto alignment, how does that work? Is that a physical, a mechanical motion, or is there some other technology you're bringing to bear?
Great question, Thomas. So this is all electronically managed. There's a software that sits behind the system. You'll be sitting in your office, and just a quick, let's say 5 minutes, you're able to get the system up and running. So it's just a matter of seconds. We do the training. Everything can be arranged very easily.
Okay, so it's a really easy system to
Yes.
set up and then also maintain, and there's really no moving parts to move or fail or interact with the
That is true.
weather.
That is
Okay,
true.
cool. So how much alignment range do you have?
We've been able to test to about 20 kilometers,
Okay.
and this is for defense purposes.
Okay.
But primarily, when we looked at most of the use cases with WISPs as well as towers, uh, even MNOs, they are very happy with anything around sub 10 kilometers. So that's pretty easy for us.
Okay, and then what about like horizontal and vertical? Like how much of a beam width do we have that it'll auto align to?
So horizontally, we're looking at anywhere between plus minus 25, and vertically, it's about plus minus 8.
Okay, cool. All right, so you have that's a pretty wide. You can eyeball and get pretty close.
That is true.
All right, and then you also have this multi-beam stuff. What's going on with that?
So what we offer is multiple point-to-point connections. So you can have multiple towers over there or monopoles over there to connect back-to-back radios. That will give you a very good range, as well as you won't see any redundancy or failover when it comes to speeds or throughputs.
Okay, cool. So and you can have redundancy, or you can build multi-paths, kind of, sort of.
Yes.
Is that just like basically Ethernet switching is effectively how that would look to my routers and devices at each tower site, or is there some sort of transport system?
So a lot of that can be achieved, and probably Venkatesha can pitch in over here.
We support the link aggregation.
Oh, okay, yeah. We'll jump over to him in just a moment so that I can get him wired up. I didn't think I was going to be. We don't plan these
just
things.
a bit more technical stuff is with him.
Okay.
But I can handle a lot of the others.
Okay. Yeah. All right. Well, we'll do a quick little jump over about how that works at the end of here, guys. Okay. So, what other cool stuff would you like to kind of talk about with the Gigamesh system?
Is it still rolling?
Yes.
Oh, okay. We can talk about, I don't know.
Features are there. Probably I will talk.
Yeah.
Multiple features are there.
Do you want me to ship?
Yeah, let's actually, we'll cut over and. All right. Now we're talking techie nerd stuff with Venkatesha. Okay, so how does the transport work between various radios?
Okay, so basically I wanted to give a quick update on what are the main features of this product that was not highlighted here. So one of them is the radio itself is highly programmable. That means we can change the encryption methodology to meet the requirements of the customers, whether it is aerospace, defense, government, or mining, oil and gas, this type of things. If there's any specific encryption mechanism, we can actually implement it in the product without changing the hardware. That's the first thing.
Okay.
Second thing is even we can increase the resilience of the link by putting say different forward error correction codes. It can be LDPC, it can be BCH, it can be combination of those things or the turbo codes. We can do so. So that way the customers can actually program or customize their product to meet the requirement of their customers. So that's the one. And the third thing is I wanted to highlight was that is basically this product is designed not only for commercial grade, it is also meant to work under very harsh conditions. So it has been tested for JSS Penta5 and MIL standard.
Okay.
And the other point you talked about was something called a link aggregation. Suppose if you wanted to provide a E-band along with one more E-band, so we have got a link aggregation provided inside the device itself. You can connect either one more E-band radio or a microwave link to ensure that the customer will get the required SLA.
Okay. We didn't talk about this earlier, but what kind of physical interfaces are we looking at? 10 gig copper, fiber?
Yes. Basically, we have got 4 interfaces. There are 2 10 gig Ethernet ports and 2 10 gig fiber ports, SFP+.
Okay. How about what's the power requirements for this radio?
The power requirements, the standard model, what you are seeing is about 60 to 70 watts. But once you go to the different models, the power will obviously will go up depending on the range.
Okay, cool. Is there anything else I forgot to bring up?
I think you have covered all those things. I believe
Okay,
so.
awesome. All right, well, it was a really
And
great...
one thing I wanted to talk about.
Yeah,
So this is basically the technology. What we are using is frequency agnostic. That means I can use it for space-to-space, satellite-to-satellite communication, satellite-to-ground communications. We can use it for V-band communications also. We are ready to give this kind of license our technology for
Okay.
suitable partners who are interested in utilizing this technology to enhance their product portfolio. And this can be used even for fixed wireless access also. For example, if you have an enterprise FWA wherein you wanted to have, say, from one node, you wanted to connect, say, three or four different nodes, but each of them have very high, say, 10 gigabit links. It is possible with this architecture.
okay, well, cool.
Right.
I'm looking forward to seeing who you can partner with. There's a ton of radio companies here at WISPA, and I know that there's some here who just come here to find other vendors to talk
Amazing,
to.
yes. Thank you so much.
Well, thank you very much for giving us your time today, guys, and we'll catch up with you later.
Sure.
Ride through space on this mothership, wireless networking. We talk about equipment and methodology, so sit back and start learning. Lighten up the tower so people can start searching. Shooting up the web in neighborhoods, net surfing. We got horrible jokes, we're loud and annoying, but we're informative facts, we're not disappointing. Just give us a listen, cause fun is the mission. I'm telling you, you don't know what you are missing. Ideas and some good comedy given. If you missed the show already, don't worry, you're forgiven.